Hi and welcome to Calculus 30 with Miss Verity. Today we're going to be looking at 7.6 inverses. So the inverse of 3, 6 is 6, 3. So remember, inverses is basically where we are just switching our x and our y in the inverse function. A reminder that reciprocals and inverses are two completely different things. Reciprocals are 1 over. Inverses, which is this little -1 symbol, that is where you're switching the x and your y. So f of 2. Okay, well, f of 2 is going to be 4 times 2 squared plus 2 times 2. 16 plus 4 is 20. So that gives us the point 2, 20. We've got an x, we've got a y. Well, so then g of 20, first of all, f of 2 is going to be 20. G of 20 is basically saying on our original function, where is our x equal to 20? Well, that happens to be at 2. And again, if you're unsure, so looking at this f-1 of 2, or inverse of 2, that's like saying on our original function, our f of x, this would be our y. So that'd be like saying this. And we'd be looking for our x. All right, so if f of x is equal to 4x squared plus 2x, x is greater than 0, and the inverse is equal to g of x, and since f of 2 is equal to 20, okay, so let's find our derivative. So our derivative is going to be 8x plus 2. Well, then f prime of 2 is going to be 8 times 2 plus 2, so 16 plus 2 is 18. Okay, I'm not going to do the whole solving for a derivative of g of x because it do be a lot. Just trust me that it is this. If you want me to solve it for you later because you're curious, I will gladly do that for you. Okay, so there's our derivative of g. We did all the fun solving for it. It involves completing the square, so that's a good time. So the derivative of g of 20, so g of 20 is equal to 1/2 times 4 times 20 plus 1 to the -1/2. So if we're simplifying, 1/2, 20 times 4 is 80, plus 1 is 81 to the -1/2. The square root of 81 is 9, and because it's to the negative, it's the reciprocal, so we get 1 over 18. Oh, interesting. Notice how those are related. Convenient. Very, very convenient. So that was our original point. So on our original, our f of x, we were looking for a derivative at 2, and that was 18. Well, on our inverse, at our essentially our y coordinate, our derivative was 1 over 18. So if we are looking for f of 4, well, f of 4 is going to be 4 times 4 squared plus 2 times 4. So 64 plus 8 is 72. So we have the point 472. So determine the derivative of 4. So f prime of 4 is equal to 8 times 4 plus 2. So 32 plus 2 is 34. So if I was to ask the derivative of g of x at 72, we would expect that derivative would be 1 over 34. It's going to be the reciprocal. 1, 6 is a point on f of x. Determine the derivative of g of x at 6. So on f of x, we know we've got, I'm just going to rewrite that. On f of x, we've got the point 1, 6. So using that relationship we established, we are on g of x, and we are looking for at 6. Well, based on that idea, we can assume that it's going to be the reciprocal of the derivative of f of x at 1. So if I say the derivative at 1 is going to be 8 times 1 plus 2, that's going to be 10. Well, then I would expect the derivative of g of x to be 1 over 10. And same with if we're determining g of 1, well, then that would be the same as finding the derivative of f of x at 6. 8 times 6 plus 2, So 6 times 8 is 48 plus 2 is 50. So then on my inverse function, I would expect the derivative to be the reciprocal. Okay, so if f of x is equal to 2x cubed, determine g of x if g of x is equal to the inverse. So remember, if we're starting like this, if I replace f of x with just a y, when I'm doing the inverse, it's switching my x's and my y's. And to find our equation, we are just going to solve for y. So I'm going to divide by 2 or multiply by 1/2 on both sides. And then I'm going to take the cube root. So I'm going to end up with the cube root of x over 2 is equal to y. So that's what g of x would be equal to. Okay, so using that idea, determine f of g of x. So remember, when I'm doing f of g of x, I'm plugging my g of x function in to my x spot in my f of x. So 2 times the cube root of 1/2 x, or x over 2 cubed. Well, a cube root cubed cancels those out, and I'm just left with 2 times 1/2 x, which is just x. And if I determine g of f of x, so again, now what I'm going to be doing is I'm going to be plugging my f of x into my x and my g of x equation. So I've got the cube root of 1/2 times 2x cubed. So 1/2 times 2 is 1. I'm left with the cube root of x cubed. Well, and the cube root of x cubed is just x. And what that tells us is if f of g of x is equal to g of f of x, and that's equal to x, then f of x and g of x are inverses of one another. And a reminder, in order for a function to have an inverse, it must be a one-to-one function, basically meaning it has to pass the horizontal line test. If it doesn't, then the domain has to be limited. What we are going to, one very important piece of information, which I'm just going to tell you, is that in order to tell if it's a function without having to graph it, if your derivative is increasing or decreasing only. So we're going to use that. So does f of x equal x cubed plus blah, blah, blah have an inverse? Well, first we're going to want to check. We could graph it, but that's lame. We've already taken the derivative. So we're going to do a sign analysis on the derivative. So we've got -1 and +1. This one switches here. This one switches here. 3 is positive the whole time. So this is positive, this is negative, this is positive. Well, based off of the previous information you just learned, the derivative isn't increasing or decreasing the whole time. So we would say, therefore, no inverse. So prove that x cubed plus 3x plus 1 has an inverse. Well, okay, so we're going to start by we are going to take the derivative. X cubed plus, let's start that again. Let's actually take the derivative. 3x squared plus 3x. Okay, so I want to do a sign analysis on this. I'm going to take out a 3x, and I'm left with a x plus 1. Oh my gosh, guys, struggle bus. Okay, let's take that derivative again, and let's try third time's a charm. 3x squared plus 3. There we go. X squared plus 1. If I'm doing a sign analysis on that, I've got 3 and I've got x squared plus 1 because that doesn't factor further. Well, x squared plus 1 never goes to 0. And if you square something, it's positive the whole way along, and you're adding 1, you're going to stay positive the whole time. So because it is positive, overall our whole window is positive the whole time, our function would have an inverse. We are going to skip over this example, and we're going to go into sine functions. So since y is equal to sine of x is not a one-to-one function, because we know sine graphs do something like that, and if we're giving it the horizontal line test, well, it fails at multiple points. So the inverse doesn't exist for all x values, but it does exist from -pi/2 to pi/2. So that's if it exists from sort of like this window. Here it's negative, here it's positive. We want to determine the values of each. So the inverse sine of 1/2. Well, we kind of want to think to ourselves, we're going to think backwards. We are going to think, okay, where is our sine equal to 1/2? So first of all, sine, next thing, we're restricting it from -pi/2 to pi/2. So our quadrant 2 doesn't really matter. It's going to be in quadrant 1. If we think of 1, 2, root of 3, we've got 30, we've got 60. We're also going to do it in radians, but where our opposite over hypotenuse is equal to 1/2 is at 30 degrees, and that is pi/6. Where's the cosine equal to 1/2? Again, in this, remember, students take calculus. I guess there would technically be 2 spots. We're just going to focus on quadrant 1 though, and that happens at 60 degrees, which is pi/3. And where is our tangent equal to? We're going to say +1. We can use either these values, like our 1, 0, our 0, 1. We can also go to our good friend, this triangle. And tangent is opposite over adjacent, and so that's at 45, which is pi/4. All right, this next step. So this is our proof for the inverse of the derivative of the inverse sine. And so if we go through that, read through that, basically, here is our good friend, our derivative. What we kind of want to look at is basically, if we're going to also do it in terms of u, which we've talked a lot about, where u is some other function, because they're not just going to be pretty x's or 3x's, that our derivative is going to be 1 over the square root of 1 minus the stuff squared times the derivative of the stuff. Next up, we've got cosine. There's our proof for it. Read through it. We've got our derivative of the inverse. So again, if we're going to turn that into terms of u's, our derivative would be equal to -1 over the square root of 1 minus u squared times du dx. Next up, we have the inverse tan. Our inverse tan, if again, we're going to switch it to be tan -1 of u, well, that's going to be 1 over 1 plus u squared times du dx. Okay, so determine the derivative of each. We're just going to do a handful of them. So the derivative of inverse cos of 2x. So using our inverse cos rule that we now know from up here, that's going to be -1 over the square root of 1 minus the stuff squared times the derivative of the stuff. And so if we simplify this, we're going to get -2 over the square root of 1 minus 4x squared. And we would leave it like that. Next up, we've got b. Reminder, we've got a product rule in here. So we've got the derivative of the first times the second plus the derivative of the second, which is going to be the square root of 1 minus the stuff squared times the derivative of the stuff, which would be 1 times the first. If we want to simplify this, we're going to take out 2 as a common factor, and that leaves us with inverse sine plus x over the square root of 1 minus x squared. Let's do c. So remember, 10 is just a constant. That's like saying this is 2x, we multiply by our constant. So 10 times our derivative of cos inverse of 5x, -1 over the square root of 1 minus 5x squared, times the derivative of the stuff. If we're simplifying, we're going to end up with -50 over the square root of 1 minus 25x squared. And last but not least, let's do f. That one looks nice and fun. All right. Negative sign. So derivative of cos is negative sign of the stuff times the derivative of the stuff times derivative of the stuff is 2. So what we have is here, kind of the fun part is sine of the inverse sine is just, that's like saying the square root of x squared. Kind of, it's like the inverse operation. So sine and inverse sine are those inverses. So that's just going to be our stuff in the middle there. So 2x times 2 is 4x over our, oh, don't forget my negative that's sitting out front, minus 1 minus 4x squared. Next up, let's take the derivative of some of these. So we've got the derivative of 6 of our sine is going to be 1 over our 1 minus ln x squared times the derivative of the stuff. Derivative of ln x is 1 over x. And simplify, this is going to be 6 over x, the root of 1 minus 2 ln x. Excellent.